Okay, so a lot of you seem pretty confused about the difference between the alternative and null hypotheses and sort of how we identify the alternative and null hypotheses. And specifically, a lot of you seem kind of confused on why we would hypothesize the null hypotheses, because it seems like the means of our samples are basically always different. And that's true, right? We will rarely ever find two random samples with the exact same mean. And that's because in any population of data, there's almost always going to be some variation. And because of that variation, um, when we take a random sample, or when we take a few random samples, we'll almost always find that the means of those samples are different. Um, uh, and so when we're asking questions about the alternative and null hypothesis in statistics, when we're asking if the means are different, what we're really asking is a question about probability. When we say the means are the same or different statistically using a confidence interval, we are actually making a statement about the probability that the means of those samples are actually different due to some cause, rather than just random chance. So we're asking the question: are the means different because of how the experimenter ran the experiment? Are they uh, different because those samples are actually, in fact, different? Um, okay, and uh, with that in mind, it might be useful to rethink our definitions of the alternative and null hypothesis. Um, so the alternative hypothesis, another way to say that would be that the means are so different that probability isn't due to random chance. So let's get a visual for that. Here we can see we've got two populations, a red population and a blue population. And we can see that the means are really far apart. There's hardly any overlap of the bell curves. When we think about the null hypothesis, we're saying that the means are close enough that their difference could be explained by randomness in the samples. And so here we've got two bell curves with a whole lot of overlap. And so what we're seeing in this second situation is that even though the means are different, which I think is kind of what's confusing a lot of you, that difference could be explained by random chance, which is why we sometimes make the null hypothesis, right? Or why we, maybe a better way to say it is why we always test the null hypothesis is, and we haven't really gotten into testing yet, that's going to be next, but when we're making the null hypothesis, we are making room for the possibility that the difference in our means could simply be caused by randomness in our sampling technique, and that our differences have nothing to do with how we ran the experiment or um, we're making room for the possibility that our samples themselves um, uh, are actually the same, right? Okay, so here, let's go through those examples from yesterday again with that in mind, and we'll kind of try to talk about things through that lens. Okay, so a credit card company wondered whether giving frequent flyer miles for every purchase would increase card usage. They tested a random sample of 48 customers and found the sample mean to be $2,498 per year with a standard deviation of $109. Then they gave free miles to 51 credit card customers and found the sample mean to be $2,542 with a standard deviation of $113. What would be a reasonable alternative and null hypothesis for this experiment? Okay, um, so first let's take a look at our means. So with no free credit card miles, and remember this X bar means mean, so the mean with no free credit card miles was 2,498. The mean with free credit card miles was 2,452. Okay, so let's develop our null hypothesis. And so we're going to be kind of going back and forth between two screens here. I'm going to represent our null and alternative hypotheses with symbols. That'll be on this page, and in the next page I'll do it with words. Okay, so the first thing that we could say is that these means are not the same, right? And that should be pretty obvious, right? That could be our alternative hypothesis, is we could hypothesize that 2,542 is different from 2,498. If we want to think about it through this new lens, though, what we could say is for our alternative hypothesis is that this difference could not be explained by random chance. So not only are these means not the same, which is obvious, but the difference in these means can't be explained by randomness in the sample. Okay, so customers who were given free miles spent a different amount of money on average than customers who were not given free miles, right? And it's not our sampling that's causing this difference. Okay, so we could also say that customers that were given free miles spent more money than customers that were not given free miles. And again, the reason that we're finding that they're spending more has nothing to do with random chance, right? That's what we're hypothesizing in the alternative hypothesis. Customers who were given free miles spent more money on average than customers who are not given free miles. Okay, we could also hypothesize, right, and this is just the reverse of option 2. We could say that on average, customers that were not given free miles spent less than customers that were given free miles. And again, this cannot be explained by random chance. That's what we're hypothesizing. Okay. And so let's start thinking about our null hypothesis. What's the opposite of saying that customers who were given free miles spent a different amount of money on average than customers who are not given free miles? So we're saying that the means are equal. This is where I think a lot of people are getting confused, because we look at those two means and they're obviously not equal, right? 2,542 is not equal to 2,498. However, when we're making the null hypothesis, we're not, I know I'm writing equals here, we're not actually hypothesizing that they're equal, but rather we're hypothesizing that the difference cannot be explained with random chance. And so with that in mind, when we say customers who were given free amount of miles spent the same amount of money on average as customers who were not given free miles, we're not actually saying that they spent the same amount of money, but rather we're saying that the difference in the amount of money spent could simply be explained by random chance, and that if we collected more data, we would find that the means are nearly the same. Okay, and so then same thing here. What's the opposite of saying that that customers that were given free credit card miles spent more money than customers that were not given free credit card miles? Well, we could say that customers that were given free credit card miles spent less than or the same amount of money as customers that were not given free credit card miles. Again, this is confusing because 2,542 is not less than or equal to 2,498. But what we're really saying here when we're making this hypothesis is we're hypothesizing that the alternative hypothesis above could be incorrect. And remember that the alternative hypothesis is saying that the reason that we found this sample to be larger than this sample is not due to random chance. And so our null hypothesis is saying, well, wait a second, maybe it isn't actually larger, right? Maybe there was just enough randomness in our sampling to explain the difference between these two values. And so that's what we're really saying with this null hypothesis. But in terms of being able to write the statement, in terms of being able to identify it on this quiz that I'm asking you to do, we're just looking for the opposite. So if we go up here, customers who were given free miles spent more money on average than customers who were not given free miles. What's the opposite of that statement? Customers who were given free miles did not spend more money on average than customers who were not given free miles. So what you really need to be able to do on this quiz is your first step is going to be to identify all of your alternative hypotheses, and they should be pretty obvious. Then you want to jump to the same question where I'm asking you to find the null hypotheses and think about what's the opposite of that statement. So the opposite of spending more money is going to be spending less than or equal to that amount of money. The opposite of spending less money, right? The opposite of spending less is going to be spending a greater than or equal to amount of money. Hopefully that kind of makes sense. And I do have another example here, but I'm already realizing this video is getting kind of long, so I think I'm going to cut it off here. But just let me know if you have any questions.